Imagine you're in the fastest spaceship ever built. You accelerate faster and faster. You pass the speed of sound. You pass the speed of a bullet. You pass the speed of Earth's fastest spacecraft. You keep accelerating until you're moving at 99% of the speed of light. Just a little more and you'll break the ultimate speed limit of the universe. But then something strange happens. No matter how much more energy you use, you still can't reach the speed of light. Why? Who put this cosmic speed limit in place? And what would happen if something actually traveled faster than light? Today we're going to explore one of the biggest mysteries in physics. Why can't anything with mass travel faster than light? First, let's understand what the speed of light really is. Light travels at approximately 300,000 kilometers per second, or about 186,000 miles per second. To put that into perspective, light can travel around Earth about 7.5 times in 1 second. It takes light only 1.3 seconds to reach the moon. Light from the sun reaches Earth in about 8 minutes. That's incredibly fast. In fact, according to our current understanding of physics, nothing can travel faster. This idea comes from the work of one of history's greatest scientists, Albert Einstein. In 1905, Einstein introduced the theory of special relativity, which completely changed how we think about space, time, and motion. And one of its most surprising conclusions was that the speed of light is the same for everyone. No matter how fast you're moving, you'll always measure light traveling at the same speed. This strange fact leads to some incredible consequences. Let's imagine you're pushing a shopping cart. A light cart is easy to push. A heavier cart requires more force. Now imagine a spaceship. As the spaceship moves faster, it becomes harder and harder to accelerate. Near the speed of light, the amount of energy needed becomes enormous. At 90% of the speed of light, you need a huge amount of energy. At 99%, you need even more. At 99.999%, the energy required becomes almost unimaginable. According to Einstein's equations, reaching exactly the speed of light would require infinite energy. And infinite energy simply doesn't exist. It's like trying to climb a staircase that never ends. No matter how many steps you take, you never reach the top. This is why objects with mass can get extremely close to the speed of light, but can never actually reach it. Now things get even stranger. As you move faster, time itself begins to slow down. This effect is called time dilation. Imagine two identical twins. One stays on Earth, the other travels through space at nearly the speed of light. When the astronaut returns, something shocking happens. The astronaut may have aged only a few years. Meanwhile, the twin on Earth may have aged decades. This isn't science fiction. Scientists have measured time dilation using extremely accurate atomic clocks. Even astronauts experience tiny amounts of this effect. The faster you move, the slower time passes for you compared to someone standing still. At the speed of light, time would effectively stop. And this creates a major problem. If an object with mass reached light speed, the laws of physics would break down. Our current equations simply don't allow it. You might be wondering, if nothing can reach the speed of light, then how does light do it? The answer is simple. Light is made of particles called photons. Photons have no mass. Because they have no mass, they don't need infinite energy to travel at light speed. In fact, photons naturally travel at that speed. For them, it's not a limit they must reach. It's their normal state. This is why sunlight can cross millions of kilometers of space and still arrive at Earth at exactly the speed of light. Now let's ask a crazy question. What if something could travel faster than light? At first it sounds amazing. Interstellar travel would become easy. We could visit distant stars in a short time. But physics predicts something very strange. Traveling faster than light could allow information to move backward in time. Imagine sending a message. Under certain conditions, the message could arrive before it was sent. That creates a paradox. For example, you might receive tomorrow's lottery numbers today, or you might warn your past self about a mistake before it happens. Cause and effect would become confused. The universe seems to prevent these paradoxes by enforcing the light speed limit. In a way, the speed of light helps keep time moving in the correct order. So why can't we travel faster than light? The answer comes down to three main reasons. Objects with mass require more and more energy as they approach light speed. Reaching light speed would require infinite energy. Traveling faster than light could break the normal order of cause and effect and create time paradoxes. For now, the speed of light remains the ultimate speed limit of the universe. But science is always evolving. Some ideas, such as wormholes and warp drives, suggest possible ways to travel vast distances without technically breaking the speed limit. Whether those ideas will ever become reality remains one of the biggest questions in science. And who knows? The next great breakthrough might come from someone watching this video right now. If you enjoyed this explanation, don't forget to like, subscribe, and let me know in the comments. If you could travel anywhere in the universe instantly, where would you go? Thanks for watching, and I'll see you in the next video.